All right. What is the first question we usually ask ourselves on these? Proper, improper. What is it on this one? Okay, this one is improper. Okay, so we've got improper, good or bad? This is the bad type. Okay, so what that means is we've got to do some long division. Now, on most of these, they've made them work out fairly nicely. Okay, this one's not going to be bad at all. So to do the long division, we're going to put an x on the outside, and then we're going to put x squared. Okay, since there's no x power, what do I, or just regular old x to the first, what do I do here? Does anybody remember from 1010? Seriously?
You have to add a 0.
You have to add a 0, okay? So you've got to save a place for a number that's not there, okay? So what that does is that just kind of keeps us nice and organized. And again, when you're doing these, it's important to make things nice and evenly spaced. See how each one of these takes up roughly the same amount of space? I write really horribly, but when I do these, I try and write really nice and keep everything nice and neat. So I look at the x and the x squared. What do I multiply x by to make it an x squared? X. So I multiply here, I get x squared. Then I'm going to subtract, so that's going to be a 0. Now I have no x's, and then I only have a -1. So what do I multiply x by to make it a -1? Can you do that? Nope. Okay, now here's the cool part. Remember, the remainder doesn't matter at all. Okay, if you look back at these notes, it says if it's the bad type of improper, it's just use long division, and it's y equals the quotient. Okay, that's all we're worried about. So on this problem right here, all we're worried about is this guy right there. That is the slanted asymptote. So y equals x is the, we could call it oblique, or the slanted asymptote. I'll just put SA for slanted asymptote. Any questions there? Sure? Okay, then let's take a look at the rest. The next thing we do with this is we factor it and find the domain issues and stuff like that. So this is going to be x minus 1, x plus 1, because that numerator is a difference of squares. And then I look at the denominator. What numbers can't I plug in? Where are my domain issues? X equals 0. Okay? Does that cancel? Can I cancel that off? Nope. So what is that? Vertical asymptote. Okay? So I've got a vertical asymptote. I have a slanted asymptote and I have a vertical asymptote. Okay, the next thing we do is we find intercepts. So I'll plug in a 0 for x. Well, wait a minute. Can you plug in a 0 for x? You can't plug in a 0 for x. So there is no y-intercept. No y-intercept at all. Plug in a 0 for y. Now again, this looks awful. If I set those two things equal to each other, this looks horrible. I've got this mess over here and I need to make it equal to 0. What's the only part of a fraction that can make it equal to 0? Just the numerator. So you get to ignore the bottom. You don't even need to worry about it. And what's the x-intercept from here? 1. And from here? -1. So I have two x-intercepts. One at -1 and one at +1. Okay. Let's start charting this information. I've got a slanted asymptote. First slanted asymptote we have, it's going to be y equals x. So that's just that perfect 45. So it looks like this.
Oh,
yeah.
How did you get the vertical asymptote of x equals 0?
Because the denominator, you find the zeros in the denominator. So what would make x equal to 0? That would be 0. And it doesn't cancel. So it's not a whole. It's just a vertical asymptote. Any questions there? Yeah.
How did you get the, how is it,
How do we know it's slanted? We have to do long division if it's the bad type of improper. So I did long division, and it's just whatever the quotient is. It's y equals the quotient. So if this was x, it's y equals x. If this happened to be x minus 2, it would be y equals x minus 2. It would be the same line moved down 2. If this was 3x plus 4, it would be a steeper line and moved up 4. Does that make sense? At this point, it's just, this is just y equals mx plus b. Okay? Any questions there? Okay, so we have the slanted asymptote. We have a vertical asymptote right here. Now, when you're drawing these, if you'll label them, a lot of times it's easier to see them, especially if it's on this axis. So x equals 0 is a vertical asymptote. Y equals x is a slanted asymptote. So I'm labeling all that stuff. And then I'm going to come back here. I'm going to use a big fat red marker here. And we're going to put these points on here. Because I've got the slanted asymptote. I've got the vertical asymptote. Now I want to put these guys on here. So it crosses at -1, and it crosses at +1. Okay, are there any questions to here? Slanted asymptotes are awesome. They're even better than horizontal ones, especially like if it's 0. Okay, it's even better than if it's 2 or -4. Because watch, from here on, all you have to do is just think about this. What's the multiplicity of each one of these zeros, these x-intercepts? 1. Touch or cross? Both of them are going to cross. So let's start along here. It's got to look like this slanted asymptote out here, right? So it's got to be going up here forever. So it's going to be along here like this. It's going to have to hit this right here. It's got to cross through it. Can it turn around and go back up? Why not? There's no more x-intercepts on that side, so it just continues on like this. It's got to run along the slanted asymptote, which is down here. When it gets to that point right there, it's got to cross, and then can it turn around and go back up? Nope, because it doesn't have another x-intercept, so that's what it looks like. You've labeled the asymptotes. We could label that as 1, 0, that is -1, 0, and that's it. Any questions? Okay. Let's see, I'll just do this really quickly. You can't use a calculator on the test, but we could double check and just make sure we got this right. So I'm going to put the top in parentheses. Remember, when you plug this into the calculator, you do have to go back to the original one. You wouldn't want to use the simplified version. Okay? And then this is going to be over x. And I put the top and bottom in parentheses just out of habit. Okay? Whenever you've got a division problem, make sure you've got the top divided by the entire bottom. So it's always a good idea to put parentheses on there. This is a pretty small graph, so I'm just going to graph this in the decimal window. And there it is. Okay, now, we started this on, what day? I think we started it on Tuesday. Didn't we? Okay, we're 3 days into this, and you can already make a ridiculously complicated graph. Doesn't take that much effort, okay? And hopefully you understand where these features come from, okay? All right, any questions? Okay. All right, 2 more. I do have a little thought question there. Why can we ignore the remainder on an improper rational function when finding the oblique asymptote? Why do we get to ignore the remainder? Okay. Shane thinks he has an idea. Everybody watch, please. This is just a thought question, so don't worry about this too much. I'm going to come back up here and I'm going to change colors. I'm going to use this big fat green marker. If we were to finish this off, this is the quotient, this is the remainder. So quotient here, remainder here, and this is the divisor. So if we were to write out what this equals, if we did long division, it actually equals x and then minus 1 over x. There's the quotient plus the remainder over the divisor. Is that okay? So why do we just use this part? Why don't we worry about this guy right here? Shane thinks he knows. Go ahead. Shane's going to take a pass on this one. Anybody else want to take a shot at it? What happens when you plug in really big numbers? Because that's what we're interested in with a horizontal asymptote or a slanted asymptote. What does it look like when we plug in huge numbers? So pick a huge number, Caitlin. 20. Okay, if I plug in a 20, this one is 20 minus 1 over 20. 20 minus a 20th. A 20th is a pretty small number, right? Okay, let's pick a bigger number. Let's make it really convenient, like say 2,000. That would be 2,000 minus 1 2,000th. So which one has the biggest impact on the overall shape when you're plugging in huge numbers? Is it the x or the 1 over x? The 1 over x. And by the way, what we've got left here is now, is it proper or improper? Proper. If it's proper, what would be its asymptote? What would it turn into if you plug in big numbers? It turns into a 0. Okay? Or it approaches 0. It gets really, really, really small. Does that make sense? Okay. All right. So let's take a look at these last couple. That's just a thought question. If you get it, great. If not, that's fine. Okay. Would you go ahead and get started on this one? I'm going to give you a 2-minute head start. You do have some problems like this, and don't be surprised if you see one on the test next Thursday. So think about how we approached those before. If you need to go back and look at the list, that's fine, but it might be good to just look at examples. We always started off by asking ourselves a question. Chase, what's the question we usually ask?
Is it improper or proper?
And which is it?
Improper.
Improper. Good or bad?
Bad.
Bad. So what do we have to do? Long division. Do we actually have to finish off all of the long division? No. Okay, so we're going to do x plus 2. And then we've got x squared plus x minus 2. So let's see, what do we multiply x by to make an x squared? That's going to be x. This is going to be a 2x, and then we're going to subtract. So these are going to go away. This is going to give me a minus x and a minus 2. And what do I multiply x by to make it a minus x? Negative 1. Okay. Now at this point, I really could be done. I don't need to finish it off. That's the quotient right there. Okay, that's going to be our slanted asymptote. Okay, I'll go ahead and finish this off. This is going to be a negative x. That's going to be a minus 2. So those both change. Happens to be that we turn out with the remainder of 0. That's going to be maybe interesting in just a second. But here's what we've got. Y equals x minus 1. That is our slanted asymptote. Okay, so there's our first piece of information from this. Okay, what do we do next? Factor. Okay, so if I can factor the top and bottom, I do. The numerator does factor. It factors to, let's see, multiply to be negative 2, combined to be positive 1.
Plus 2.
X plus 2 and x minus 1. Does that work? Okay, remember, I mentioned the other day, please double check that. Make sure you factored it correctly. It would be horrible if you went through the rest of the problem and you figured out you factored it wrong. So these multiply to be x squared. These multiply to be negative 2. There's a 2x and there's a minus 1x. That would be positive x for the middle term. And then this is x plus 2. Now, when we've got it right here, what's the domain issue? We can't ignore that. What number can we not plug in? Negative 2. Does it cancel?
Yes.
It does. So what is this? It's a whole. Okay? So what's the simplified version? The simplified version is x minus 1. When does that equal 0? When x equals 1. Okay? So we've got one x-intercept. Oops, negative 1. Do we have a y-intercept at all? What do you get when you plug in a 0 on the top and the bottom? What do you get when you plug in a 0 here? You get a negative 1. If you plug in a 0 here, you get a negative 2 on the top and a 2 on the bottom. So you get negative 1 either place you plug it in. Okay? Okay, everybody watching? Okay, 1, 2, 3 pieces of information. I've got the horizontal or slanted asymptote, vertical asymptotes or holes, and then I found the x and y intercepts. So let me slide back up here. 1, 2, 3 pieces of information. Slanted asymptote, vertical asymptote, and then x and y intercepts. Yeah, Tatum? Oh, sorry. There you go. That's why. Okay, because I made a mistake.
That's on the asymptote.
Yeah, that right there. Yep. Made a mistake there. Transferred it down there incorrectly. Everybody good there? Thank you for pointing that out. Hate to make those mistakes. Okay, any questions to here? Okay, let's start charting this information. Slanted asymptote. It's just y equals mx plus b. So the slope is 1, the y-intercept is -1. So it crosses here and has a slope of 1. So it's going to look something like this. So I'll just do a dotted line. Crosses here. Crosses here. Let's see, it's got a hole at -2. So we're going to have a hole. And let's see, it crosses at 0, -1. So let's put that on the graph, 0, -1. Now, is it okay that that's on the slanted asymptote? Is that okay? Yeah, it just can't be on a vertical asymptote. And are there any vertical asymptotes on this one? Nope. Okay. Crosses at 1, 0. So right here. And this is the simplified version. So if I simplify this, it looks like x minus 1. It looks like this line. So this is a weird one. It looks like exactly like this line the entire time. Is that a true statement? Not quite. Okay. What does this right here remind me of? There's a hole in the graph. There better be a little hole right there. So if I were to make this look right, I'd do this. That's what it looks like. There's no vertical asymptote on this one, so we don't have branches and that sort of thing. We just have a line with a hole in it. Yes?
So the line actually runs along.
Right on the asymptote. Doesn't happen very often, okay? But occasionally it can. If everything in the denominator cancels, you'll just be left with that. Okay? You believe me? Okay, let's take a quick look. Grab your calculator. Again, you want to plug in the original one. And you want to plug it in parentheses. So we're going to do parentheses, and then x squared plus x minus 2, close the parentheses. Again, the entire top divided by the entire bottom. So the bottom is going to be x plus 2, close the parentheses. And then I'm going to graph this in the standard window. That looks pretty good, right? Looks just like our graph, except for it doesn't have a hole in it. Okay, you could find it by doing this. Let's type in the number -2, because we know that's where it occurs. Hit enter, and notice it says there's no value. Even though it looks like there isn't a point on the graph there. So let's make this look a little bit better. Let's hit zoom and hit 4. This is that decimal window. See how you can see it right there? Okay, I'm going to slide this down just a little bit. I'm going to change the window. I'm going to go, let's see, let's go -4.1, 2.1. There it is. Doesn't that look just like our graph right here? Okay. Doesn't happen very often that you end up with a straight line with a hole in it, but occasionally it will. It's a little more typical to see something like this. Maybe a branch like this, and then a branch like this, and then maybe something with a hole right here. Okay, something like that. That's a little more typical, because then you'll have asymptotes and a hole. Okay, are there any questions? Sure? Okay. That's kind of an oddball. Let's take a look at this last one. This, I think, is a lot more typical. So, Kylie, what's the first question we ask ourselves here? And which is it? What is it? Okay, this one is, notice how they're the same? So this is improper, but is it the good or the bad type? It's the good type. Okay, which means it's y equals the leading coefficient over the leading coefficient. And so that's 1 over 1. So that quick, we have our horizontal asymptote. There's our first piece of information. Okay, JC, what do we do next? The math F word. Factor. Okay, so we're going to factor this. If we can factor it, we want to factor that. So we're going to see if we can factor x squared minus 5x plus 4. We need two numbers that multiply to be positive 4 that combine to be negative 5. Multiply to be positive 4, combine to be negative 5. Those will multiply to be a negative 5. Negative 4 and negative 1. That'll do it. They'll multiply to be a positive. They'll combine to be a negative. Good there? Okay, the denominator, we need numbers that multiply to be negative 4 and combine to be negative 3. Multiply to be negative, combine to be a negative. Okay, so negative 4 and positive 1. Negative 4 and positive 1. Any questions there? Okay, so then we look at this and we say, well, what can't we plug in? We can't plug in a 4 and we can't plug in a negative 1. But I do get to cancel this one right here. So what does that mean happens at 4? Okay, so we've got a hole at 4, and what do we have at negative 1? Vertical asymptotes. Okay, problems in the domain that cancel are holes. Problems that stick around are vertical asymptotes. Okay, so we've got this guy right here. Horizontal asymptote, vertical asymptotes, and holes. The next thing we found was intercepts, x and y intercepts. The easiest one to find is the y-intercept, so let's plug in a 0. You can plug it into the simplified version, or you can plug it into the original one. It doesn't matter. If I plug a 0 in here, I get a 4 on the top and a negative 4 on the bottom. That would be negative 1. If I plug a 0 in here, I have a negative 1 on the top and a positive 1 on the bottom. That's going to be negative 1 also. So the y-intercept is negative 1. Now, when I'm finding intercepts or x-intercepts, it's best to use the simplified version. So let's look at this guy right here. The only part I need to worry about is the numerator. And what makes this equal to 0? 1. Let's make sure I transfer this down here correctly. This is a positive 1, right? So this is a 1, comma 0. So there's the other piece of information. By the way, let's just take note here. What's the multiplicity of this 0? It's 1, so it crosses there. Okay, I think we've only had one x-intercept in this section where its multiplicity was even, so it touches. Okay, are there any questions? Okay, let's start charting the information. Y equals 1. So there's our horizontal asymptote. Vertical asymptote at negative 1. What do we do for the hole again? Just draw a little line, okay? So we'll draw one about that big, little dotted line, and we'll write hole x equals 4. And then let's put some points on the graph. 0, negative 1. 0, negative 1 right here. 1, 0 right here. How many pieces here? How many branches? 2 branches. 1 over here and 1 over here. Now the 1 over here has a hole in it, but that's not a big deal. We can deal with that. Okay, would you just sketch what it would have to look like? I don't think you even have to pick a point. Just use your head, think about what it means. We've got this horizontal asymptote, it's got to run along there out near the ends. And as it gets near the middle, as it gets near the vertical asymptote, it's either got to go up or down. It's got to do one of the two. Got to run along here and then make a choice, either up or down. Got to run along here, hit these points, and then either go up or down. Josh, can you tell me something about the piece over here on this side? All positive, right? Every bit of it. Because if it's got to run along here, it's already above the x-axis, right? It's already positive. And then as it gets close here, it's either got to go up or go down. Why can it not go down? No x-intercept, so it's got to go up. And this piece right here has got to run along here, have a hole right here. It's got to cross. Can it turn around and go up? Nope. Got to go down like that. Okay? That's what it looks like. Okay, are there any questions? Okay, just real quickly. You don't need to do this, but I'm going to turn this back on. I'm going to edit this. This is going to be a -5, and then this is a +4. And then in the denominator, we've got parentheses x squared minus 3x, and then -4. I'll close the parentheses. So that's the original graph. So when I hit enter, it should graph this. So let's see what we've got here. If I hit zoom 6, there's our... Does it look pretty good? Okay, but you can't see the hole, and it's tough to see right where that would be. So I'm going to hit zoom 4. Okay, there's that upper piece. Now take a good look. See that little hole right there? There we go. Okay, we can double check that. We'll hit trace, and I'll enter a 4. It says there's no value there. Has a little hole in the graph, and it'll even tell you there's not a value. Okay, are there any questions? Sure? Okay, let's see. So on 4.4, if you look at the instructions, it says use steps 1 through 7. That's the stuff we've been talking about. If you need to refer to that, it's in your notes. It's right there. But that's the stuff. Those are the steps we've been going through. If you do those, then you're just fine. What's that? Exact same thing. Okay. Any questions? Okay. Who's done with 4.3? Raise your hand. Excellent. Thank you very much. Okay. Has anybody started 4.4? Not bad. Okay. What's the first problem on 4.4? Number 1. Okay. Go ahead and do number 1 right now, please. If you've already done number 1, pick up wherever you left off. Okay, that's it. Number 1 on page 339. It's on 4.4.